Hey everyone, Mr. Hauk here. In today's video, we're going to look at the 24 problems in the all levels activity or assignment for trig verifications. Okay. Now, before I get started on this, just be aware that some of these are pretty tough, especially some of these from the advanced level, section 3, can be pretty challenging. I'm going to go through all 24 of these proofs. I am not going to start them from scratch. That video would be very, very lengthy. So instead, I've already got all 24 of these proofs worked out, and I'm more going to annotate over them and kind of talk about what I did for these proofs. Okay. So we start here with number 1 and 2. So we're trying to verify or prove that cosine squared of x over sine of x plus sine of x equals cosecant. And what I did here is I wanted to go ahead and get a common denominator. So think of this sine of x over 1. And I went ahead and multiplied both sides of this by sine of x over sine of x. And this gives me that common denominator of sine so that I can add these together. So now I'm going to have cosine squared plus sine squared, because sine of x times sine of x is sine squared, over sine of x. Cosine squared plus sine squared is an identity. That's going to give us 1. And then 1 over sine is cosecant. And that finishes our proof for number 1. So pretty easy beginner level verification there for number 1. Number 2, we were trying to verify that tangent of x over 1 minus cosine squared is equal to secant of x times cosecant x. I'm going to work on the left side here. I notice right away that 1 minus cosine squared is sine squared. And notice, by the way, I forgot to point this out with number 1. Any identities, I went ahead and highlighted to show you what the identity turns into, okay? So this being highlighted in yellow is saying that cosine squared of x plus sine squared of x is 1. So back to our proof over here. 1 minus cosine squared is an identity. That's going to be sine squared. Now we have tangent x over sine squared. And this is where I'm going to decompose things into sines and cosines. So I'm going to decompose tangent x into sine x over cosine x. I'm going to write sine squared as sine squared over 1, just because I know a lot of students prefer to kind of see it that way. And at this point, this is set up really nicely for a keep, change, flip. So we're going to keep the numerator, sine of x over cosine x, change the division to multiplication, then flip the denominator to be 1 over sine squared. Once we've done that, we can see this sine squared and this sine. Remember, sine squared is really like sine times sine, right? So one of these sines will cancel with this sine. We're left with 1 over cosine times 1 over sine. And we know that 1 over cosine is secant, and 1 over sine is cosecant. And that finishes our proof. Okay, so there's numbers 1 and number 2. Two pretty beginner-friendly proofs, in my opinion. All right, in number 3, we're trying to prove that secant to the 4th of x minus tangent to the 4th of x equals tangent squared of x plus secant squared of x. I ended up working on the left side here, and notice we have a difference of 2 squares. Difference being subtraction, and secant to the 4th and tangent to the 4th are both perfect squares. So using difference of 2 squares, this will factor like this. Secant squared of x plus tangent squared of x times secant squared of x minus tangent squared of x. Notice that secant squared of x minus tangent squared of x is an identity that's equal to 1. And all we're going to have left is secant squared of x plus tangent squared of x, because it's just multiplying by 1. And that's exactly what we wanted to prove anyway. All right, problem number 4. We want to verify that cosecant of x plus cotangent of x equals 1 plus cosine of x divided by sine of x. I'm going to go ahead and decompose into sines and cosines. So cosecant, that's 1 over sine. Cotangent of x, that's cosine x over sine of x. Notice that when you decompose into cosines and sines, they already have common denominators. So I can add the numerators, 1 plus cosine of x, keep our common denominator, but that's exactly what we wanted to verify anyway. So we're done with our proof. All right, 3 and 4, again, two pretty beginner-friendly proofs. Let's move on to 5 and 6. All right, problem 5, we want to verify that cosecant squared of x times tangent squared of x minus 1 equals tangent squared of x. I'm going to go ahead and decompose into sines and cosines. So cosecant squared of x, that's 1 over sine squared. Tangent squared of x, that's sine squared over cosine squared. And of course we have our minus 1. Since these are multiplying together, we can cancel between the numerator and denominator. That's going to leave us with 1 over cosine squared minus 1 equals tangent squared. Now, 1 over cosine squared is secant squared. And once we make that little change, secant squared of x minus 1 is an identity, and secant squared of x minus 1 is tangent squared of x. And that's exactly what we wanted to prove anyway. All right, problem 6, we want to verify that 1 minus sine squared of x times 1 plus tangent squared of x equals 1. These are both Pythagorean identities. 1 minus sine squared is cosine squared. 1 plus tangent squared is secant squared. At this point, I went ahead and turned them or decomposed them into sines and cosines. So cosine squared, you can leave it alone. You can put it over 1 if you want to. Secant squared is going to be 1 over cosine squared. And we can see that after multiplying, we get cosine squared over cosine squared, which is 1, and that's what we wanted to prove. So we're done. All right, problem 7, verify secant of x minus tangent x times sine of x equals cosine of x. And I'm going to go ahead and decompose into sines and cosines. Here's secant of x, 1 over cosine, tangent of x, sine over cosine, sine of x, I'm going to leave it alone, put it over 1 if you want to. And at this point, notice that we're going to get common denominators. Denominator here is cosine. Denominator over here is cosine times 1, which is still just cosine. So we can combine the numerators, 1 minus sine squared over the common denominator cosine. And 1 minus sine squared is a Pythagorean identity, which is cosine squared. Now cosine squared divided by cosine is just cosine, which is what we wanted to prove. All right, problem number 8, cosine squared of x minus sine squared of x. We want to verify that that's equal to 1 minus 2 sine squared. And what I decided to do here is I went ahead and changed this cosine squared into 1 minus 2 sine squared, or not 1 minus 2, 1 minus sine squared rather. And part of the reason I'm doing this is because if you look at what we want it to equal, we want it to equal 1 minus 2 sine squared. So getting or rewriting this cosine squared in terms of sine is going to help us achieve that goal. Now, negative 2 sine squared, negative 2 sine squared. Think of this as like a minus 1 sine squared and a minus 1 sine squared, which will give us minus 2 sine squared. And we carry this 1 down with us, which is what we wanted to prove. Okay. So with 7 and 8 there, that's the end of our kind of beginner proofs, our beginner verifications. Now we move into the intermediate verifications, which are going to be a pretty significant jump in challenge and difficulty, but overall, they shouldn't be too bad. All right. So number 9, we want to verify that secant of x times sine of x divided by tangent of x plus cotangent of x is equal to sine squared. First step, just like with many of these problems, I'm not noticing any Pythagorean identities to use, so I'm going to decompose into sines and cosines. Secant is 1 over cosine, tangent, sine over cosine, cotangent, cosine over sine. Sine, I just write as sine over 1. You don't need to put over 1, of course. At this point, sine over cosine, that's what's going to happen here. Down here in the denominator, we're trying to add 2 fractions, and we're going to need common denominators. So I'm going to multiply this, which has cosine of x. Well, I need a sine of x with it in the denominator, so I'm going to multiply by sine of x over sine of x. This denominator is missing the cosine of x, so I'm going to multiply by cosine of x over cosine of x. And at that point, notice sine of x times sine of x, that's sine squared. This is cosine squared. So we have sine of x over cosine x, the original numerator, over sine squared of x plus cosine squared of x over sine x cosine x. Now we know that sine squared plus cosine squared is 1. And then I'm going to do keep, change, flip. Keep sine of x over cosine x the same. Flip this denominator. Remember, this is a 1. So we get sine x cosine x over 1. Cosines are going to cancel because we're multiplying, and we're left over with sine of x times sine of x, which is sine squared. And that's the end of our proof. All right. Number 10, I start this problem with a Pythagorean identity. 1 plus tangent squared is secant squared. And then at this point, I'm going to go ahead and decompose into sines and cosines. This tangent squared right here is going to decompose into sine squared over cosine squared. This secant squared is going to decompose into 1 over cosine squared. And this 1, well, we want a common denominator, so I'm going to multiply it by cosine squared over cosine squared. After doing that, in the numerator here, we have cosine squared minus sine squared over the common denominator cosine squared divided by 1 over cosine squared. Now notice when you have a fraction, when you have two fractions in a big fraction, if their denominators are the same, we've seen many times they will cancel out, leaving us with cosine squared minus sine squared over 1, which is just cosine squared minus sine squared. Next, cosine squared, that's a Pythagorean identity. Let's replace it with 1 minus sine squared. And then finally, 1 minus sine squared minus sine squared. Well, this gives us minus 2 sine squared, and we carry that 1 down, which is what we wanted to prove. All right, almost halfway there. Number 11. We want to show that secant squared of x over secant squared of x minus 1 equals secant squared. Secant squared of x minus 1, that's an identity. That's tangent squared. And then once we're at that point, I'm going to go and decompose into sines and cosines. So secant squared decomposes into 1 over cosine squared. Tangent squared decomposes into sine squared over cosine squared. Notice again, fraction over a fraction. Denominators are the same. They'll cancel. Now we have 1 over sine squared equals cosecant squared, but 1 over sine squared is cosecant squared, and we're done with our proof. All right, number 12. One of the, I think it's one of 4 problems where I recommend actually working on the right side versus the left side. And the reason I recommend working on the right side here is because we can see this denominator, 1 minus cosine of x, and we can actually multiply top and bottom by 1 plus cosine of x, and it's going to allow some nice little cancellations to happen. So the left side, I'm going to leave it alone the whole time. Working on the right side, cosecant gets distributed. So cosecant times 1, there's cosecant. Cosecant times cosine, that's just cosecant times cosine. Nothing we can really do there. And then in the denominator, we FOIL. So 1 times 1, there's our 1. 1 times cosine, there's cosine. Negative cosine times 1, there's negative cosine. And negative cosine times cosine, there's negative cosine squared. In that denominator, notice we have some canceling pieces, cosine minus cosine, and we're left with 1 minus cosine squared. And this is the reason we multiplied by this 1 plus cosine on top and bottom, is because it gives us this identity in the denominator. We know that 1 minus cosine squared is sine squared. And if we look at these pieces, by the way, common denominator of sine, we can just add the numerators, so that's 1 plus cosine on top. And then lastly, we'll do some good old keep change flip. 1 plus cosine over sine times this thing flipped upside down. And that's going to give us 1 plus cosine over sine cubed, which is what we wanted to prove. Okay, so pretty nice little problem there. Showcases a cool little technique right up there at the top. All right, now we're a little more than halfway through the problems. However, the problems get a little tougher. Looking at number 13 here, let's decompose into sines and cosines. So cotangent, cosine over sine, secant, 1 over cosine, cotangent, cosine over sine, cosine, leave it alone, or put it over 1, your choice. And at this point, I'm actually going to do keep change flip twice. So keep the cosine over sine, flip the denominator, 1 over cosine. Over here, keep the 1 over cosine, flip this denominator to sine over cosine. Over here on this left side, cosines cancel, you get 1 over sine. Right over here, nothing cancels, you get sine over cosine squared. Now at this point, we have denominator sine and cosine squared. So I'm going to multiply by the pieces they're missing to get a common denominator. I know I want sine and cosine squared in the denominator, so I'll multiply here by sine over sine, and here by cosine squared over cosine squared. By doing that, in the numerator, you get cosine squared plus sine squared over sine cosine squared. And we know cosine squared plus sine squared is 1. And then we're almost done with this problem here. I went ahead and broke this up into 1 over sine of x times 1 over cosine squared. The 1 over sine is the cosecant. 1 over cosine squared is the secant squared. And that's what we wanted to prove anyway. Okay. Okay, number 14. I think this is the only problem in the 24 problem set that I would recommend working both sides at the same time. And you're going to use pretty much the same strategy. We're going to decompose into sines and cosines, so everything gets decomposed. And then we're going to work on common denominators. So I've got this cosine x over sine of x right here. I'm going to multiply this 1 by sine x over sine of x to get that common denominator of sine. And same deal over here. I have the sine of x over cosine of x. Multiply top and bottom by cosine x over cosine x. Get that common denominator of cosine. When you do that, you get sine of x plus cosine x over sine of x divided by 1 over sine of x. Sine of x is cancel. Over here, you get cosine x plus sine of x over cosine x divided by 1 over cosine x, and the cosine x is cancel. And notice that gives you sine of x plus cosine x equals cosine x plus sine of x, which is the same thing, and there's the end of our proof. If you would have tried to work on, for example, the left side completely alone, it would have worked, but it would have been much more difficult. Okay. All right, problem number 15. Verify that sine of x over 1 minus cosine of x equals cosecant x plus cotangent x. So I see this 1 minus cosine of x. It's not an identity, by the way. It doesn't have the squared. We can't just turn that into sine of x. I've had a lot of students ask me that. You can't do that. So, but I can force it to be an identity by multiplying by 1 plus cosine of x over 1 plus cosine of x. So I'm just taking this denominator and I'm changing the sign in the middle, multiplying it to the top and bottom. So on top, we get some distributing going on. You know, sine times 1 is sine times cosine is just sine cosine. In the denominator, we end up foiling. We get these pieces right here. Cosine minus cosine cancels. You're left with 1 minus cosine squared, which again, that's a Pythagorean identity. So that's great. That's going to make the problem easier because that 1 minus cosine squared is going to turn into sine squared. And also notice in the numerator, I noticed that both these terms have signs in common, so I just factored the sine out. And when you factor the sine out, what's left over is 1 plus cosine. Now, this sine, don't want to go over there yet. This sine and this sine squared, they are going to reduce with each other. So remember, sine squared is like sine times sine, right? One of these will cancel with this up here. So all we have left over is 1 plus cosine over sine. And then let's separate the fraction. 1 over sine of x plus cosine of x over sine of x. 1 over sine of x is cosecant. Cosine over sine is cotangent. And that's what we wanted to prove to begin with. All right. Number 16, I think this is the last of the intermediate level before we get to some of the advanced ones. So number 16, sine of x plus cosine of x squared plus sine of x minus cosine of x squared. We want to show it equals 2. Now, one thing that I had a lot of students try to do that you're not allowed to do, you can't just sit here and take this squared and say, okay, well, that's going to make these two squared. That's not how it works. It's got to be foiled, okay? So this really means sine of x plus cosine of x times itself. Same thing for this piece. Sine of x minus cosine of x times itself. Doing all the foiling work here, this is going to be the result of foiling this. This is going to be the result of foiling this. Notice that you're going to get a 2 sine of x and a minus 2 sine of x to cancel. All the pieces left over, sine squared plus sine squared is 2 sine squared. Cosine squared plus cosine squared is 2 cosine squared. I'm going to go ahead and factor the 2 out. So pull the 2 to the outside. On the inside, we get sine squared plus cosine squared after factoring the 2, which is an identity. We know that's going to equal 1, and 2 times 1 is 2, which is what we were trying to prove to begin with. Okay, but again, I want to stress this one more time. You cannot take a 2 on the outside of these parentheses and just stick them there and there. That does not work. Okay, that's bad. No, don't do that. It's got to be FOILed. Okay, so I believe these are the advanced level problems, the last 8. And some of these get a little tough. Some of them are not too bad. Some get pretty tough. So, number 17 here. We want to verify that cosine of the fourth of x minus sine of the fourth of x is 2 cosine squared of x minus 1. We have a difference of squares. Difference. Both of these are perfect squares. So it's going to factor into this. Cosine squared plus sine squared times cosine squared minus sine squared. This right here, cosine squared plus sine squared, is a Pythagorean identity that's equal to 1, leaving you only with cosine squared minus sine squared. And then sine squared, we also know to be 1 minus cosine squared. Now, where you have to be very careful here is the fact that this sine squared is being subtracted. So when you replace the sine squared with 1 minus cosine squared, the minus sign, because of the subtraction, ends up getting distributed. This is going to give us a minus 1, but a positive cosine squared. Cosine squared and cosine squared, both positive, give you 2 cosine squared. Then you carry the minus 1 down, and that's the end of the proof. All right. Number 18. We want to prove that tangent of x plus cotangent of x squared equals secant squared plus cosecant squared. Once again, this has to be FOILed. We cannot sit here and just say, hey, those carry over. It doesn't work that way. So we got to FOIL these things. So tangent times tangent, there's tangent squared. Tangent times cotangent, you're going to get tangent cotangent. But then you get a second one when you do the inside pieces. So you really end up getting 2 tangent cotangent. And then we have cotangent x times cotangent x, which is cotangent squared. Notice, though, that tangent times cotangent, well, first off, they're reciprocals of each other, so they're going to give you 1 anyway when you multiply. But if you want to see why they give you 1, tangent is sine over cosine, cotangent is cosine over sine. All these pieces cancel. You just get 2 times, really this all turns into a 1. Okay. So now we have tangent squared plus 2 plus cotangent squared. And I'm going to do something kind of clever here. I'm going to take this 2. I'm going to break it up into 1 and 1, because tangent squared plus 1 and cotangent squared plus 1 are both Pythagorean identity variants. We know that tangent squared plus 1 is secant squared, but we know cotangent squared plus 1 is cosecant squared, and that's exactly what we wanted to prove. Okay, so clever little, separating of the 1 into, or separating of the 2 into plus 1 and plus 1. All right. Both 19 and 20, I actually end up working on the right side. Again, what kind of tells me to work on the right side is this denominator being 1 minus sine. Same thing over here. I know I can use this nice little technique of multiplying by 1 plus sine over 1 plus sine on both sides. So that's what I end up doing here. So we're multiplying by 1 plus sine over 1 plus sine. You have to FOIL the top and the bottom, so just be careful with your foiling. And this is the result of what you get when you FOIL top and bottom. Notice sine of x minus 3 sine of x, that's going to be minus 2 sine of x. In the denominator, sine of x minus sine of x cancels. You get 1 minus sine squared. And we know that 1 minus sine squared, that's a Pythagorean identity variant, is going to be cosine squared. And that's exactly what we wanted to prove. Okay. Number 20, same deal. I'm going to choose to work on the right side instead of the left side as usual. I'm going to multiply by this denominator, but we change the sign, of course. So multiply by 1 plus sine of x over 1 plus sine of x. This cosine gets distributed, so cosine times 1 is cosine. Cosine times sine of x is just cosine x sine of x. And denominator gets FOILed, which gives you these pieces right here when you FOIL. Now, of course, when you FOIL those, sine of x and negative sine of x cancel each other out. You get 1 minus sine squared, which is a Pythagorean identity variant. 1 minus sine squared is cosine squared. Also notice in the top, both of these terms have a cosine of x in common as a factor, so I factor it out. We get 1 plus sine of x remaining. And the reason that's important is because once we factor this cosine of x out, now that we've kind of turned the denominator into cosine squared, these can reduce with each other. So this cosine of x is going to go away. This will become cosine of x, and we get 1 plus sine of x over cosine of x, which we're almost done with. Now we're going to go ahead and separate the fraction. So 1 over cosine of x, that's secant of x. Sine of x over cosine of x, that's tangent of x. And that's our desired result. All right. I think number 20 through 24 are huge pain. If you can do these and understand these, that's awesome, by the way. But they're pretty complicated. So, number 21 here, tangent of A plus tangent of B divided by cotangent of A plus cotangent of B. We want to verify that that's equal to tangent of A times tangent of B. Now, first things first, I'm going to decompose everything into sines and cosines. So the tangent, the cotangent, the tangent, and this cotangent all get decomposed. And in both the numerator and denominator, I want to get common denominators. So I have a cosine A and a cosine B. I'm going to multiply by the pieces that they're missing. So I'm going to multiply here by cosine B over cosine B. Multiply here by cosine A over cosine A. Then I do the same thing in the big denominator. I've got sine A and sine B, so let's multiply by the pieces that they're missing. And when we do that, with these common denominators, then we can add the numerators together. So we have sine A cosine B plus cosine A sine B over the common denominator, cosine A cosine B, over, same deal here, cosine A sine B plus sine A cosine B, that's this, over the common denominator sine A sine B. Then we do keep, change, flip. This is where we get to see something pretty neat happen. So when you do keep, change, flip, and this gets flipped upside down, notice that sine A cosine B plus cosine A sine B is common to both of these pieces. And since we're multiplying, we can cancel between numerators and denominators, meaning that all that's left is sine A sine B over cosine A cosine B, which sine A over cosine A is tangent A, sine B over cosine B is tangent B, and that's the desired result. So everything checks out. Like I said, kind of a pain of a problem, took a lot of space, but that's how that one works. All right, number 22. Again, pretty tough problem here. We want to verify 1 plus sine of x plus cosine of x divided by 1 plus sine of x minus cosine of x is equal to 1 plus cosine of x over sine of x. This is hard to see, but if you multiply both the numerator and denominator by 1 plus cosine of x, it's going to make our lives a little bit easier. Now, there's a lot of multiplying that has to go on, but watch what happens here. So let's multiply this times this. 1 times 1. Or really, I'm just actually going to leave these alone. They actually turn out to simplify later on. So let's just go and multiply the bottom. 1 times 1, there's 1. 1 times cosine of x, there's cosine of x. Sine times 1, there's sine. Sine times cosine of x, sine x cosine x. Negative cosine times 1, there's negative cosine. And then negative cosine times cosine, there's negative cosine squared. Notice that the cosine of x and negative cosine of x cancel. So our new denominator, we have the sine of x, the sine x cosine x. And I very strategically decide to move the 1 minus cosine squared together next to each other to really show that we can use this and turn it into sine squared, as that's a Pythagorean identity variant. So by doing that, watch what ends up happening here. It's pretty cool, pretty clever. Once we've made that change, everything in the denominator has the greatest common factor of sine of x. So I factor out the sine of x in denominator, and I get sine of x plus 1 plus cosine of x, which is going to cancel with this 1 plus sine of x plus cosine of x. Remember, addition, you can do in any order you want. So those pieces are really the same. They cancel. You're left with 1 plus cosine of x over sine of x, which is the desired result. That's what we wanted to prove anyway. So, cool problem, just a little hectic, a little chaotic in that problem. All right, almost done. 2 more to go. All right, number 23, we're trying to show that sine of x plus tangent of x over 1 plus secant of x is equal to sine of x. There's 1 plus secant of x on the bottom. I'm going to use that same old little trick that we've been doing where we multiply by whatever the denominator is with the sign in the middle changed. So we multiply by 1 minus secant of x, top and bottom. Then we go through and we start to FOIL. So sine times 1, sine times negative secant, tangent times 1, tangent times negative secant. There's our top. On the bottom here, same deal, 1 times 1, 1 times negative secant, secant times 1, and secant times negative secant. In that denominator, negative secant and secant, when you add them together, they cancel, they give you 0. In the numerator, a lot of stuff going on here. I'm going to go ahead and decompose into sines and cosines. So, this sine of x stays the same. We don't need to change it. Sine times secant, that's going to be sine times 1 over cosine. Tangent, which is sine times sine over cosine. And then tangent times secant, sine over cosine times 1 over cosine. And notice that when we combine those pieces up top, this is negative sine over cosine. This is positive sine over cosine. They cancel, leaving you with sine minus sine over cosine squared. And then we have an identity in the denominator, 1 minus secant squared. It's actually negative tangent squared. So that kind of brings us down to this step right here. Now, in the numerator, we're still trying to subtract fractions, so we need that common denominator. So this sine over 1, it's going to get multiplied by cosine squared over cosine squared. And that's going to allow us to take the sine cosine squared minus sine, put it over the common denominator of cosine squared. And I'm going to decompose this negative tangent squared into the negative sine squared over cosine squared. And notice, we've seen this several times now. Two fractions, if the denominators are the same and they're being divided, they're going to eliminate. So now we have sine cosine squared minus sine over negative sine squared. That's where we are right here. And the numerator has a greatest common factor of sine. So I factor out the sine of x. We get cosine squared minus 1, which, by the way, is an identity. And then this sine over negative sine squared. Again, this is like sine times sine. One of these will cancel with this up here. So we have negative sine left over in the bottom. Cosine squared minus 1 in the top, which is really negative sine squared. And negative sine squared over negative sine is just sine. So sine of x equals sine of x. Pretty crazy problem. Definitely on the difficult side. Hopefully that all makes sense. And then our last one of our advanced bracket. We want to prove that tangent squared of x times sine squared of x is equal to tangent squared of x minus sine squared of x. I'm going to work on the right side for this problem. I'm going to do difference of squares. Tangent squared minus sine squared is going to be tangent of x plus sine of x times tangent of x minus sine of x. I'm then going to decompose into sines and cosines. Okay. Once you've decomposed into sines and cosines, we need a common denominator. So here in this one, we want a common denominator of cosine, so we multiply by cosine over cosine. Here we also want a common denominator of cosine, so we multiply by cosine over cosine. And we start to simplify here. So this is going to give us sine plus sine cosine over cosine, right there. This is going to give us sine minus sine cosine over cosine, right there. And notice what I do here is I go ahead and in each of these numerators, they both have common factors of sine. So, factor the sine of x out of here, we get 1 plus cosine x. Factor the sine of x out of here, we get 1 minus cosine x. And now we can multiply. Sine times sine, there's sine squared. 1 plus cosine times 1 minus cosine. I'm going to leave those alone for right now. And then in the denominator, cosine times cosine, cosine squared. Now we can go ahead and FOIL these two. When you FOIL them, you're going to get 1 minus cosine squared. Two of those pieces, the inside pieces, they'll end up canceling. And we know that 1 minus cosine squared is sine squared. So now we have sine squared times sine squared over cosine squared, which I'm going to break into. So notice I'm going to break this into sine squared over cosine squared, right there, times the sine squared that's left over, right here. But sine squared over cosine squared is tangent squared. This sine squared carries down, and that's our desired result. So we're done with that proof right there. Okay. again, 16 through 24, pretty tough. These are pretty, or rather 17 through 24, sorry. Pretty advanced level, trig verifications. Hopefully all those made sense. If you need to go back and watch parts of the video again, that's, it's perfectly understandable. But it's a pretty good challenging assignment. All different levels, bunch of different algebraic techniques that were showcased. So hopefully you found this helpful. Hopefully this, kind of helps you in your trig verification proofs. And see you in the next one.